welcome back to Fixx. And in this video I have a Intel solid state drive that I've already removed from a laptop as it was no longer being detected. So I'm interested to see why this thing's failed, and even better if we're able to repair it as well. Brilliant. Let's take it over to the mat and see if we can work it out together. Okay, so the story with this hard drive is that as I say, it just seemed to die in the laptop and it's no longer being detected. Even if you go into the BIOS, it's not even detected in there as well. So it seems to be completely dead. So yeah, I think I'm going to have to open it and try and get into this. It would be nice to revive this with the data on it, because I have an old version of Windows 7 installed on this with lots of like legacy software. So it's in a laptop that I use with Windows 7 where things won't work on a modern machine. But I think the first thing I'm going to do is try and put it into my dock. I'm currently just working on a few other drives, copying files, so I'm going to wait for those to finish, and I'm going to put it into my dock and see if it's detected on my computer or not. Right, there's no point in showing you on the computer, but there's completely nothing detected. It's not even coming up as a uninitialized drive or anything like that. It's just completely dead, and it doesn't show up in any of the partition software that I've got, or it doesn't also show in the BIOS on this machine, as well as obviously the machine it came out of as well. So I'm not familiar at all with how these work. So as a starting point, what I've done is I've printed out the connector pinout for these two connectors, for the SATA connectors here. Now, so we've got the larger and the smaller one. I would have assumed that the smaller one would be the power in, and then this would be for data. But looking at the pinout, it's not the case. The larger connector here is the power, and this is where the data is. Because this is completely dead, not doing anything, I'm assuming it's going to be power related on this connector. Now, there's a bit of an exploded diagram here of this connector, and it looks like a lot of these are just ground points on here, but you've got the first 3 pins are plus 3 volts. Yeah, we've got 3 volts on these 3 pins, then it's separated, and then you've got a 5 volt and you've got a 12 volt, so there's 3 different voltage rails on this, separated by these ground connectors. So I think even before taking this apart, I'm just going to do a quick measurement and see if there are any shorts on these power rails on the connector here. Now, I'm assuming they're not, because I don't know if my little dock that I had would go into some kind of protection mode, or it might switch off the light for it. But there was no light at all, so from the start, so I'm not sure. But let's see. We'll use one of these ground pins here and take a measurement on there. So yeah, pin 4 is where the ground starts. So 1, 2, 3, 4 on here, and let's go on that 3 volt rail. Let's just confirm these ones are definitely ground. Yeah, 3 volt. No, we've not got a short on that 3 volt. So let's go along. So we've got ground, 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 and 5 volt. No, we've not got a short on there. Then these should be the 3 grounds. Interestingly, that one's not. So we've got 1. There's no ground on there. Ground, and these are our 3 12 volt. And again, they seem to be fine as well. Not sure why we're not getting the ground on this last one here. Is that the one? Yeah. So this one in the middle doesn't have a ground, but we do have the other grounds either side, so I'm assuming that's fine. Let's just check these data lines, see. So we've got ground on that one and that one. So these 3 larger ones are all ground. Let's have a look on the diagram, see if that should be the case. Yeah, and that looks correct. We've got a ground, ground, and ground on these 3 there that are grounded. So on the outset, everything looks to be fine on here. So let's open it up and see inside if we can find out maybe what's causing the problem. Do a visual inspection. I think I'll start just by taking this shield off, and it looks like it's got 4 screws, probably one. Yeah, I can feel one is hidden under this sticker here. Okay, foil is off, which reveals a bit more information about this SSD. Got a product number on there in case you've got this similar one. Let me get a screwdriver for that. Okay. Right, revealed that screw underneath there. I can fold that back after. Not that it really matters. Not too precious about this. Right, will this just pry apart now? Oh yeah, that's nice and easy. Okay. So what we got here? These all seem to be the same, so I'm assuming that they are where the data's held on these chips. Does it say what size they are? SK Hynix. Well, we've got 6 chips on there, so 256 divided by 6. Can we take this out fully? Yes, we can. Let's set that to the side. Oh, okay, we've got more on this side as well. We've got another 6 here. And this looks to be our main control chip. Alright, let's bring this zoom in a bit closer and do a visual inspection, see if we can see anything obvious. So on this side of the board we've got these 3 big coils, so I'm assuming that's kind of our power section. There isn't really any coils on this side, so let's focus our efforts around here. Can we follow the tracks on here? Okay, let's start with this then. So these ones in the middle were our 5 volt on here, and they go into this little IC here. These ones at the bottom here was our 12 volt, and this one here is our 3.3. So yeah, I really can't see anything obvious. Let's have another look around here. There's quite a lot on this. Are they discoloured? These capacitors. They do look slightly different colour to them. No, I've had a good look around and I can't see anything obvious on here, so nothing really interesting to show you. I'm wondering if I can power this up and then just measure and see if my voltage rails are present first of all while this is connected to the computer. Ideally I'd like to measure from this side because I can see the pins nice and clear, but if I'm connecting it to my dock it has to go in this way. But I think we can still get on the pins in here and check them if we look at the reverse of that, and we can measure it that way. So let's try that first of all. Right, we're connected to the dock now, and let's power on. Okay, so hopefully we've got everything in shot here so we can take some measurements. I'm going to take the ground off this hole here. We should have 3.3 on these first pins, so let's just check that first. And we've got nothing. Yeah, there's nothing there at all. What about the 5 volt? It's about here. No, nothing. 12 volt. No, nothing at all. Is this ground good? Let's just check that. Are these good grounds? Alright, I need to, inside of the ring is not, I need to be on the outside there. Let me check that again. Get back into volts DC, and let's check these first ones. No, nothing there. 5 volt, nothing there. 12 volt. Ah, right, okay. So we have got 12 volt, but it's dropping. This is strange. So get in focus. So we've got 12 volt and it's dropping right down. So it looks like it was on there. Let me switch this off and power cycle it. See if we get 3 volts initially while it thinks about it. I'm struggling to keep on the ground here. 1 second. Right, I'm in better with the ground now, so let's just try again on that 3.3. There's definitely nothing in there. 5 volt. Let's just run along these pins until we get to there, and we get 12 volts again and dropping. So yeah, something's not right here. So we're only getting 12 volts and our 3.3 and 5 volts are not present. Can I feel anything warming up? I'm going to quickly stick the thermal cam on this and just see if I can see anything heating up. Right, under the thermal camera we've got nothing at all. There's absolutely no hot spots on there. You can see some shining bits, but yeah, there's nothing. I mean, I can only see one side of the board, but if something was getting hot on the other side of the board, I think we'd see that coming through with a dispersed heat. So I don't believe anything's getting hot. I'm going to have a look, see if there may be any fuses in here. Okay, I found a fuse here. Let me just check this. Yeah, that's fine. I've just been looking at this cover that was under the foil, and it does say on here that it's 5 volts, 0.8 amps. So perhaps it's only requiring the 5 volts to operate on here. Now, I'm not sure because the old IDE drives on there used to use, I know, 5 volts and 12 volts. This has got a 3.3 and the 12 volts, but maybe it is only using this 5 volt. So I think I'm going to try and follow this 5 volt line and see why this isn't present, because maybe if we get the 5 volts, this will work. It's the next day now, and I tried to continue doing this video and doing some measurements on this, but to be honest, I got annoyed. Other people on YouTube make it look quite easy, but in reality it's actually quite difficult to take measurements with your probes. Especially I was probing in here and I can't really see exactly what pin I'm on, and my ground hole kept slipping off here as well, so I had to walk away from it. And the other problem was, as I'm connected into here, I can't take any measurements on this side of the board, which would be much easier to get to the pins on the bottom of here. So as I say, I've come up with a few solutions today. Last night I bought this cable here, and that will allow me to connect into here, so I can get rid of this dock. And also I don't want to damage that dock as well, because it's more expensive. So I've just got this cheap USB to SATA adapter, but that will give me the ability just to spin it around. So I can now have it on this side and take measurements, which will be a lot easier. And to go along with that as well, I already have this tool, which I've not really used yet, but this is my USB power meter. So my idea is as well, is try and connect this to the computer, and I'll be able to actually see if this is drawing any current. It gives me a bit more of a visual on what's going on. because at the moment I can't see any current draw and I wasn't getting any voltage measurements. And the last thing that I'm going to do as well is say, because my ground kept slipping off here, I've just made up a little cable here with a ferrule on it, and I'm just going to solder that onto one of these ground points now, so it gives me a fixed place attachment to get a nice ground on there, and then I can use the other probe to take some proper measurements now. So let's get this soldered on and let's continue with the diagnostics. Let's just tap this on. I've already applied a little bit of flux. I've got some solder on here. Okay, that should be fine. Right, I think we're winning. I've got my probes. I've put a crocodile clip into my multimeter now. Let's just attach onto this ferrule. Lovely. And now we should be... Right, we've got a good ground now. Let's have a look. Oh, it's so much easier rather than having to try and hold that on. Yeah, that's going to be fine. Yeah, lovely. Like, we can get on with it now. Right. Now we're just working with one probe. I think we can speed run this. So my plan is, let's just go through every capacitor on here and make sure we've got no shorts on here. So find everything we see. Usually one side should be shorted. Yes, that's shorted. Ground plane. This one. Only one side. Have we got any more? We've got some little ones up here. Only one side on all that bank. Have we got any more capacitors? Yes, we've got something down here. One side. Now I'm not looking at the resistance measurement, I'm just purely just taking a quick beep test on these. Only one side. That side. What we got down here. One side. Sorry if we're going out of focus. And we've got some more up here. Oh, yeah, that side. Some more up here. All looking good. We've got a bank here. And another bank here. It looks like each of these chips has got a row. Sorry if we're drifting out of focus here. Okay, let's go other side of the board. I'm now quite interested around these power circuits. Have we got anything here? So let's have a look. Oh. Okay, first one I've went on. So we've got a short here. I'm assuming, yes, they are capacitors. Let's turn that around. C81 and C82. These two capacitors. Let me get an ohms reading on those ones and show you that. Okay, I've got my multimeter in ohms now. So it was these two that are shorted. Let's have a look at them now. So 0, 0, that must be our ground side. Let's check the other side. 42 ohms. Guessing this one will be the same. 42 ohms as well. Yeah, because they're in parallel. That's probably not the issue. I thought it might be lower than that, but 42 ohms is probably correct, but I'm not sure. So let's continue going around in beat mode just to see if I can see anything else. I might speed this up a little bit. Yeah, what I'll do is I'll just go through these and come back once I've finished if I find anything. Are these inductors here? Or are these capacitors? Yeah, they look like capacitors. So off camera, I've gone around and literally every capacitor that I can see on this board, I've gone and had a buzz round, and I can't see anything obvious. The lowest I'd got is on these two capacitors here. I'd got that 42 ohm short on there, and I don't know whether that's normal or not. So I think I'm going to go back to voltages now and check those missing voltages and see if I can take some measurements on the correct pins. Now I can turn the board that way round and just confirm that those voltages are missing in. And I'm assuming because you've got three big coils on here, these probably are for the different power rails. Maybe one is a 3.3, one is a 12 volt, and one is a 5 volt. So it'd be interesting to see which one's which. And now we know that this drive should be on the 3.3. Might be able to see if we can check continuity between the connector of the 3.3 and maybe which power rail it's going to on here. I've set things up now, so I've got a USB-C going to my computer. So let's try and do some testing. Let's connect this to the USB-C input on the meter. So yeah, we've got 5 volts here from my computer. And now we can use this new adapter to connect this up and measure some voltages. But having this in line, we'll be able to see if it is drawing any current as well, which will be interesting to see. So yeah, I'm not actually sure how this works because obviously we've got a 5 volt input to the computer, but this has got to generate a 5 volt, a 3.3 and a 12 volt, so it must have some kind of circuitry in here, maybe like a buck boost converter to step up, step down the voltage. But yeah, let's go ahead and connect this USB lead, and it'll restart. With this meter, if you want it to stay on all the time, you need to have a micro USB connected, but I'm happy just to wait for it to restart. Okay, let's plug in now. Yeah, with the right way. Do have a blue light, and we're plugging in, and I've seen that shoot up to 0.4, and it is drawing current. Interestingly, we've got 0.3 of an amp on here, so 320 milliamps. So that's interesting, and we couldn't see that with the other dock that I've got because I didn't have this in line. So something is taking current. I think before measuring anything, yeah, let's just get the thermal camera back out on this, just double check it, because I could only check one side of the board. Now I'm able to spin it around and check both sides. Maybe there is something drawing current, which will be on this side of the board here that we didn't check. Okay, so I'm still on my meter drawing 0.3, and I've got a definite hotspot on here. It does look to be diffused, so I think it's actually now on the other side of the board. So let me turn around that. Oh, okay, so that looks like it's the main IC that's drawing current on there. Let me just put the macro lens on. The macro lens on, I can definitely see it looks like it's coming from this IC, and I don't know if you can see there, but there seems to be one particular hotspot on the chip right in the corner there, in the center, sorry. So I think this IC might be toast. Let me just double check on this side of the board. Yeah, and you can see the heat coming through the board, but it's not localized on any of these capacitors on this side. So yeah, I mean, I think, yeah, let me switch back to the normal camera. So personally, I think this is dead current that's being drawn in there, and I've checked around obviously those capacitors. There's nothing shorted obvious. I think it's an internal short on this chip here that's failed, because this is also connected to my computer as well, so it's not actually working. I still can't read anything off this board, but yeah, this chip, can't see anything obviously wrong with it. There's a bit of discoloration on there, but I think that was just where like the heat pad was on the bottom of the on the shell. It had the heat pad that sits on that chip to cool it down, so I think this has just reached end of its life and that chip's died. And here's a closer look at this chip in question. It's a Seagate chip. Now, if this was a more expensive drive, could probably go about trying to get one of these chips and replace it. I mean, I don't know if that would work. I'd like to know if anybody's got any experience. I'm assuming the memory chips like these ones, I don't know whether they would need to be replaced as well, whether they've kind of got some hard-coded hardware address that's married to this chip, or whether you could just replace that chip. But as this isn't really an expensive drive and I can quite easily replace it, I think the best thing to do is probably call it quits with this one. But I'll post this video anyway, even though I wasn't successful. And if you do have any suggestions on what else we can try, if there is any other things we can do to get this one working again. But if not, be able to use this maybe for some parts. Maybe something useful on this that I can keep and use to repair something else, because I've got no donor parts at all at the moment, so even for little capacitors and things like that might still be useful. So all in all, even though we haven't repaired this, I have managed to, I think, narrow it down to this main IC on the board, so it's been quite a good learning process on there. The only one thing kind of confuses me is that when it was in this dock and I had it under the thermal camera, couldn't see anything, but when this one, it was heating up. So I can only assume that this dock here has got a bit more of a protection circuit in it, and it, you know, cutting down the power because it's seeing an issue. So yeah, I think it's got some short circuit protection in there, whereas this one, it's probably still pushing the voltage into the device, even though there's still a fault on there. So yeah, I'm happy as well. Picked up a few extra tools along the way, a few extra techniques, which are going to be useful for further repairs. But yeah, if you've got any questions or advice about this or repairing hard drives in general, I'd love to hear from you. So leave it in the comments, and yeah, hopefully see you in the next one. Bye.